Uh, can this X3, the feature cross, truly enable a model to fit nonlinear data? Let's play with it. This is X3 as a product of X1 and X2, and this is X1 and X2. This is the same data distribution, a similar data distribution that I was showing in the slide. And as you can see, when we use only X1 and X2 linear X2 features, so you cannot segregate within 4 quadrant. And when we add the third edition engineered feature, which is feature cross, it does really do the job. And as you can see here, you can manually change the weight. Let's make it 1 here, you see, and you don't even need X1 and X2 anymore. So let's say if you increase this a little bit, wait, you see, it's not helping. So you can keep it at 0. And if you change this X2 weight, you see, it's not helping. It is, we don't even need that. So only we would need this cross feature, which is almost perfectly. So we can change the, let's increase the in a positive value. Wow. So if you really increase the weight, it's a perfect quadrant, but in real words, let's say a positive number will do the job. Let's try a negative one. You see, when you change the negative one, unfortunately, it's not predicting right. So this is it. Obviously, there are some more complex feature crosses. We can play with it. So if you would like to play with the more complex features, you can come and look at the Google machine learning crash course, and so with using TensorFlow Playground, you will understand this feature cross better. That's all. Thanks for watching this video. See you on next session.